So now we're going to look at the theorem. So our second translation theorem is if I have f of s is equal to the Laplace transform of f of t and a is greater than 0, then the Laplace transform of f of t minus a times the Heaviside function of t minus a, it equals e to the negative as of f of s. So a couple things have to be there for us to be able to do this. The first being that you see that these have to be exactly the same. If they're not in that form, then I'm not able to do it. So I'm going to have to algebraically manipulate it in order to get it into the right form. And you can see that this is always t minus a, right? So when you identify a, it's always the opposite sign. But when you go to write it out, it's e to the negative as. So really, in this case, this negative a is going to be the same negative a up there. So keep that in mind as we're going through. All right, so Laplace transform u of t minus 2. So again, this a is equal to 2, but I really want negative a. So it's going to be e to the negative 2s times the Laplace transform of just 1. And we know that the Laplace transform of 1 is 1 over s. So that gives me e to the negative 2s times 1 over s, which is just e to the negative 2s over s. Right? So f of t is just going to be 1. All right, number 2. I have the Laplace transform of t minus 3 to the 4th power times the unit step function of t minus 3. So here, these match, so that's good. They have to match, right? And then a is 3, so this is negative a is negative 3. So when I go to plug it in, it's going to be e to the negative 3s. And then the basic function here is just t to the 4th. So the Laplace transform of t to the 4th. So that is going to be 4 factorial over s to the 5th. So I get e to the negative 3s of 4 factorial over s to the 5th power. And you can multiply it out if you want. So I'd bring that 24 out front. E to the negative 3s over s to the 5th. So I want the Laplace transform of t times the unit step of t minus 2. So this time I have a problem because they don't match. So in this case, I'm going to have to add and subtract to get it to match. So I'm going to take that t there, add 2 to it, and subtract 2 from it. And that will give me t minus 2 plus 2 u to t minus 2. So we're going to kind of pull these things apart. I'm going to take this as a unit, the t minus 2, and distribute it, and then I'll have the 2 and distribute that separately. Okay. So now these are the same. Our a is equal to 2. So that just gives me e to the negative 2s times the Laplace transform without that translation. It's just t. So we have the Laplace of t is just 1 over s squared. So we get e to the negative 2s over s squared. Now the second part, I just have 2 that I can really just pull out front. So I have a in this case is equal to 2. Pull that 2 out front, so we have 2e, and then it's negative, so negative 2s, and then just the Laplace transform of 1, which is 1 over s. So this second part gives me 2e to the negative 2s over s. And if we want to put them together into one, we can by multiplying the second one by s over s. So it would end up e to the negative 2s plus 2s e to the negative 2s all over s squared. Alright, the next example, we have the Laplace transform of 3t minus 6 times the unit step function of t minus 2. So these don't match, but they almost match, right? If I factor a 3 out of there, then these match. So I can take a 3 out. And that 3, really, I could just pull it all the way out front. Okay, so now I see this negative 2. So my a term is 2, but again, it's always the negative of it. So I end up with 3e to the negative 2s. And the Laplace transform, after that shift is taken away, it's just t, which gives me 3e